Imagine a fighter jet so advanced, so packed with next-generation technology that it doesn't just dominate the skies, it defines them. Now imagine that each one costs nearly $1 billion. Not a fleet, not a prototype, one single aircraft. That's the estimated price tag of America's Next Generation Air Dominance Program, or NGAD, the sixth-generation stealth fighter that's meant to replace the F-22 Raptor. And while that number might sound absurd, the reasons behind it are both fascinating and terrifyingly logical. Because in today's world, air dominance isn't about just flying faster or higher. It's about mastering an entire ecosystem of artificial intelligence, hypersonic weapons, advanced materials, electronic warfare, and human-machine teaming. Each of these technologies alone would have been revolutionary a decade ago. Together, they create a machine so complex that even the engineers designing it admit, it's like building a spaceship that happens to fly in the atmosphere. Let's start with what NGAD actually is. Unlike previous fighter programs that centered on a single aircraft, NGAD is more of a system of systems, a connected network of manned and unmanned platforms that operate together as one lethal organism. The centerpiece is the manned 6th-gen fighter, designed for unmatched stealth, range, and adaptability. But it will fly alongside loyal wingman drones, semi-autonomous aircraft capable of surveillance, jamming, or even firing weapons themselves. The fighter doesn't just command them, it collaborates with them, forming a constantly adapting swarm powered by AI decision-making. That's where the costs start to explode. Building a stealth airframe is already astronomically expensive. The F-22 Raptor, once considered a technological marvel, cost around $150 million per jet in the 2000s. And even then, the US canceled production after just 187 units because it was too costly. The F-35 Lightning II, with all its promises of affordability and versatility, ballooned to nearly $120 million per aircraft for the early variants. NGAD's target cost? Somewhere between $300 million and $450 million per airframe, before factoring in the AI systems, drone integration, and development overhead. Once all those are included, experts estimate the true cost could reach a staggering $1 billion per tail when production, support, and research costs are spread across a smaller fleet. Why smaller? Because NGAD won't be mass-produced like the F-16 or F-35. Its role isn't to fill the skies, it's to command them. Think of it as the tip of a digital spear, a limited number of highly advanced aircraft leading formations of cheaper, more expendable drones. But even that approach doesn't reduce cost as much as it seems, because the systems that make this integration possible, secure data links, autonomous flight control, threat recognition, AI, are cutting-edge, classified, and extremely hard to develop. The Air Force has hinted that NGAD will use a modular open architecture, meaning its internal systems can be upgraded rapidly without redesigning the entire aircraft. That's critical for future warfare, where software evolves faster than hardware. But building a platform that can be reconfigured like a smartphone while maintaining stealth and reliability adds enormous engineering challenges. Every sensor, circuit, and code line has to interact flawlessly in real time under extreme conditions. Then there's the materials problem. The NGAD stealth will go beyond radar-absorbent paint. It will rely on metamaterials, specially engineered surfaces that bend electromagnetic waves in unnatural ways. These materials are incredibly expensive to research and even harder to produce consistently. The manufacturing tolerances are microscopic, and even minor imperfections can compromise stealth. The same goes for thermal management. At Mach 2+ speeds, every square inch of the airframe heats up like a furnace. Managing that heat without betraying the aircraft's infrared signature requires revolutionary cooling technologies, ones that right now barely exist outside of classified labs. And that's before we even touch the AI systems. Unlike current fighters, which rely heavily on the pilot, NGAD will function more like a co-pilot relationship between human and machine. The onboard AI will process sensor data, identify threats, and even make split-second tactical decisions, freeing the pilot to think strategically. But training that AI requires simulating millions of combat scenarios, feeding it data from decades of flight testing, and continuously validating its behavior to ensure reliability and ethics. That level of machine learning development isn't just complex, it's astronomically expensive. Now layer on cybersecurity, because when your aircraft depends on artificial intelligence and digital connectivity, hacking becomes as dangerous as missiles. NGAD must be hardened against cyber attacks at every level, from its communications to its flight control software. That means quantum encrypted data links, secure cloud-based mission planning, and advanced intrusion detection systems. Each layer of defense adds both cost and development time, but without them, a $1 billion jet could be rendered useless by a single line of malicious code. Weapons are another major cost driver. NGAD isn't being built for today's weapons. It's being designed around tomorrow's. That includes hypersonic missiles, directed energy weapons, and smart munitions that can communicate mid-flight. To carry and launch those without compromising stealth requires new internal bays, advanced cooling for laser systems, and an electrical power grid far beyond anything in current fighters. Traditional jet engines can't provide that alone, so engineers are exploring adaptive cycle engines, power plants that can switch between high-speed and fuel-efficient modes, offering unprecedented performance and range. But these engines are incredibly complex and still in testing, adding billions in R&D. Compare that to the F-22 or F-35, which were designed for 4th and early 5th-gen threats. NGAD will face hypersonic missiles, advanced radar arrays, and enemy swarms of autonomous drones. To survive that environment, it must be nearly invisible, smarter than everything around it, and capable of commanding digital battle spaces spanning hundreds of miles. It's not just an aircraft, it's a flying supercomputer. And therein lies another problem: data. The sheer amount of information NGAD will process is unprecedented. Real-time sensor fusion from satellites, drones, ships, and ground stations means terabytes of data per mission. To make sense of that in milliseconds, the jet will rely on AI algorithms trained in classified simulations. Algorithms that require massive computing clusters and thousands of engineers to maintain. The software cost alone could rival the price of a small nation's defense budget. Historically, every generation of fighter has been exponentially more expensive than the last. The F-4 Phantom II in the 1960s cost about $2.4 million per jet, roughly $20 million in today's dollars. The F-15 doubled that, the F-22 quadrupled it, and the F-35 nearly doubled again. NGAD isn't just following that curve, it's breaking it. The combination of stealth, autonomy, hypersonic readiness, and digital warfare integration has pushed the cost curve into uncharted territory. But here's the uncomfortable truth: it might still be worth it. Air dominance isn't just about prestige, it's about deterrence. When adversaries know you can strike anywhere, anytime, without being detected, that alone can prevent wars. The US military understands this all too well. The NGAD is designed not to fight fair battles, but to ensure no battle ever becomes fair for the enemy. Still, critics argue that pouring hundreds of billions into a handful of jets might not make sense in a world of drones and cyber warfare. Why build a $1 billion fighter when you can deploy 100 AI drones for the same price? The Air Force's answer is simple: survivability. Autonomous drones are powerful but vulnerable. A manned NGAD backed by AI and stealth serves as the ultimate command hub, orchestrating drone swarms, conducting deep strikes, and defending carrier groups in contested airspace. It's the brain of the operation, not just another weapon. Then there's the industrial-based challenge. Only a handful of companies in the world can even attempt a project like this. Lockheed Martin, Boeing, Northrop Grumman. The specialized materials, precision manufacturing, and classified systems require facilities that are almost national assets. Keeping that expertise alive costs money, and the Pentagon knows that canceling programs like NGAD could collapse entire supply chains. So part of the cost isn't just the jet, it's the infrastructure to keep America capable of building jets like it in the first place. As NGAD inches closer to flight testing, comparisons to past programs are inevitable. The F-35 was plagued by delays, cost overruns, and software glitches. Lessons that the Air Force insists have been learned. This time, they're using digital twin technology, fully virtual models of the aircraft that can be tested and modified in cyberspace before physical prototypes are built. This approach has already shortened design cycles, but the software and simulation tools behind it are themselves billion-dollar investments. Some insiders believe the real cost of NGAD won't be in dollars, but in opportunity. Every $1 billion fighter built means fewer resources for drones, satellites, or next-gen missile defense. The Air Force has to balance prestige and practicality, knowing that future conflicts may rely as much on data and automation as on raw air power. But for now, NGAD represents America's bet that air superiority, true unchallenged dominance, still matters. One thing's clear: it's a technological marvel that captures the essence of 21st century warfare: precision, data, speed, and secrecy. The price may be astronomical, but for the United States, maintaining dominance in the skies has never come cheap. As the NGAD program continues to evolve, it's also redefining what a fighter jet really means. The traditional concept of a single-seat aircraft dogfighting in the skies is giving way to a networked, AI-driven ecosystem of manned and unmanned systems working together seamlessly. This fundamental shift requires not just new technology, but a complete overhaul of training, maintenance, and doctrine. Pilots will no longer just fly jets. They'll command fleets of autonomous drones, analyze data in real time, and make split-second decisions with AI assistance. The future of air combat is less about speed and maneuverability, and more about who can see, decide, and act first. And as always, if you found this breakdown fascinating, don't forget to like, share, and subscribe for more deep dives into the engineering, economics, and strategy behind the world's most powerful machines.